two-speed motor is indeed another term for a part-winding motor. A part-winding motor is an electric motor designed with two distinct windings. Each of these windings is connected to a separate section of the stator. This configuration enables the motor to operate at two different speeds. The speed at which the motor operates is determined by which winding is energized. Typically, these two windings are connected in series for low-speed operation and in parallel for high-speed operation. The speed ratio between the two available speeds is dictated by the ratio of the number of turns in each of the two windings. Two-speed motors find frequent application in scenarios where having two distinct operating speeds is advantageous. Examples of such applications include fans, pumps, and compressors. Let's delve deeper into the construction and operation of a part-winding motor. As mentioned, the key feature is the presence of two separate stator windings. These windings are electrically isolated from each other. When one winding is energized, the motor operates at a specific speed. When the other winding is energized, the motor operates at a different speed. The design of these windings, specifically the number of turns in each, is crucial in determining the speed ratio. For low-speed operation, the windings are connected in series. This means that the current flows through both windings sequentially. The combined impedance of the two windings in series results in a low current flow and consequently a lower motor speed. The torque produced at this lower speed is generally higher than what would be achieved with a single winding. Conversely, for high-speed operation, the windings are connected in parallel. In this configuration, the current is split between the two windings. The overall impedance is lower, allowing for a higher current flow. This results in a higher motor speed. However, the torque produced at the highest speed may be lower than that at the low speed. Specific design parameters of the motor, such as the wire gauge, the number of turns, and the stator lamination material, all contribute to the motor's overall performance characteristics. When selecting a two-speed motor for a particular application, several factors need to be considered. Firstly, the required speed range is a critical consideration. The motor's speed ratio should match the application's needs. Secondly, the load characteristics must be taken into account. The motor should be capable of providing sufficient torque at both speeds to drive the load effectively. Thirdly, the motor's power requirements should be evaluated. The motor should be sized appropriately to handle the load without overheating or experiencing excessive voltage drop. Fourthly, the operating environment should be considered. Factors such as temperature, humidity, and altitude can affect the motor's performance. Fifthly, the control system should be compatible with the two-speed motor. The control system should be able to switch between the two windings seamlessly and provide appropriate protection against overloads and short circuits. Two-speed motors offer several advantages over single-speed motors in certain applications. One advantage is the ability to optimize energy consumption. By operating at the lower speed when the load is light, the motor can consume less energy. Another advantage is reduced noise levels. The low-speed operation can result in quieter operation, which is desirable in some environments. A further advantage is increased flexibility. The ability to switch between two speeds allows for greater flexibility in controlling the driven equipment. However, two-speed motors also have some disadvantages. One disadvantage is increased complexity. The dual-winding design adds to the complexity of the motor and its control system. Another disadvantage is higher cost. Two-speed motors are typically more expensive than single-speed motors due to the added complexity. A further disadvantage is reduced efficiency. The efficiency of a two-speed motor may be slightly lower than that of a single-speed motor, particularly at the lower speed. In summary, a two-speed motor, also known as a part-winding motor, offers a versatile solution for applications requiring two distinct operating speeds. Its dual-winding design, with series and parallel connections, allows for efficient speed control, while offering advantages such as energy optimization and increased flexibility. It also presents challenges such as increased complexity and cost. Careful consideration of the application requirements and motor characteristics is essential for selecting the appropriate two-speed motor. When working with electric motors, it is important to adhere to all relevant safety precautions and electrical codes. Always disconnect power before working on any electrical equipment. Use appropriate personal protective equipment such as gloves and safety glasses. Consult with a qualified electrician if you are unsure about any aspect of the installation or repair process. Understanding the principles of operation and the various design considerations of two-speed motors is crucial for engineers and technicians involved in motor selection, installation, and maintenance. The ability to optimize motor performance and efficiency can lead to significant energy savings and improved system reliability. Furthermore, troubleshooting and diagnosing problems in two-speed motors requires a thorough understanding of their unique characteristics. By following proper safety procedures and adhering to industry best practices, you can ensure the safe and efficient operation of two-speed motors in a wide range of applications. It is also worth noting that there are different types of two-speed motors available. Some motors use a technique called pole changing to achieve different speeds. These motors have a different internal configuration compared to part-winding motors. In a pole-changing motor, the number of magnetic poles in the stator winding is changed, which directly affects the synchronous speed of the motor. Another type of two-speed motor uses a variable frequency drive, often abbreviated as Volts-FD. A Volts-FD allows for continuous speed control over a wide range, rather than just two discrete speeds. However, using a Volts-FD adds to the complexity and cost of the system. When comparing a part-winding motor to a pole-changing motor, there are some key differences. Part-winding motors are generally simpler in construction than pole-changing motors. However, pole-changing motors can often achieve a wider range of speed ratios. The choice between the two types depends on the specific application requirements. The National Electrical Code, or NEC, provides guidelines for the installation and wiring of electric motors. It is important to consult the NEC to ensure that the motor is installed correctly and safely. Some relevant NEC sections include those covering motor overload protection, motor branch circuit protection, and motor grounding. Specific NEC tables, such as Table 430.250, provide full load current values for motors of different sizes and voltages. These tables are essential for selecting the appropriate size of conductors and overcurrent protection devices. In addition to the NEC, there may be local electrical codes and regulations that must be followed. Always check with your local authorities to ensure compliance with all applicable codes. Proper maintenance is essential for ensuring the long life and reliable operation of two-speed motors. Regular maintenance tasks include lubricating bearings, cleaning windings, and inspecting for loose connections. It is also important to monitor the motor's operating temperature and vibration levels. Excessive heat or vibration can indicate a problem with the motor. If any problems are detected, they should be addressed promptly to prevent further damage. When troubleshooting a two-speed motor, it is helpful to have a wiring diagram and a multimeter. The wiring diagram can help you identify the different windings and connections. The multimeter can be used to measure voltage, current, and resistance. Some common problems with two-speed motors include open windings, shorted windings, and ground faults. These problems can be diagnosed using a multimeter. It is also important to check the motor's control circuit for any problems. The control circuit may include relays, contactors, and switches. These components can fail over time and cause the motor to malfunction. When replacing a two-speed motor, it is important to select a replacement motor that has the same specifications as the original motor. The replacement motor should have the same voltage, horsepower, speed, and frame size. It is also important to ensure that the replacement motor is compatible with the existing control system. Before installing the replacement motor, it is important to thoroughly inspect it for any damage. Check the windings for any signs of overheating or damage. Also, check the bearings for any signs of wear or looseness. If any problems are detected, the motor should be returned to the supplier for replacement. After installing the replacement motor, it is important to test it to ensure that it is operating correctly. Check the motor's speed, current, and voltage. Also, check the motor's vibration levels. If the motor is not operating correctly, consult with a qualified electrician to troubleshoot the problem. In conclusion, two-speed motors offer a versatile solution for applications requiring multiple speeds. Understanding the principles of operation, the various design considerations, and the proper maintenance procedures is essential for ensuring the safe and efficient operation of these motors. By following proper safety procedures and adhering to industry best practices, you can maximize the performance and lifespan of two-speed motors in a wide range of applications. Remember to always consult with qualified professionals when working with electrical equipment, and prioritize safety above all else.